Okay, 6.2 is going to be a short one. Again, better have a pencil and paper ready. I do not want you watching this video more than once. I want you to be referring to your notes. As I said, this one, we are going to be focusing on 6.2, and that would be sequences as recursive formulas. Okay, let's get started. Recap. Tn. In your own words, what would that be? For me, I would say something along the lines of the nth term of a sequence of numbers. The nth term in a sequence of numbers. Okay. Well, the interesting thing about this is there are some sequences that just can't be expressed by normal explicit formulas. Okay. Let me type that out. I think it's a really important part. There are, there are some sequences that just cannot be expressed as an explicit formula. For example, one example would be one of the sequences I gave you in the previous video, and that is the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, so on and so forth. Certain sequences must be written using what we call a recursive formula and not an explicit formula. Why? Because the future terms are generated from using previous existing terms. Okay? Maybe I should write that down again. Okay. Some sequences have terms that are generated from previous terms. In other words, the previous term needs to exist if you want any clue of how to get the next term. One example for the Fibonacci sequence, if I want the next term here, which you might guess is 13 plus 21, 34. If you wanted 34, both 21 and 13 needs to be provided. You need to know what that is. And so we have something called the recursive formula. Okay, so let me just go through it. Starting with the first three terms here. Term 1 is 1. Term 2 is 1. How do we get term 3? Well, it was term 2 added to term 1, which equal to 2. How do you get term 4? Well, it was the previous term added to the term before, which is 2 plus 1, and that's a 3. So on and so forth. One last time, T5. The fifth term, which I don't know yet, is the fourth term added with the third term, which would be 3, because the fourth term is a 3, and 2, because the third term is a 2. And that gives us 5. Okay? Which always brings us to, of course, mathematicians always looking for that formula. What's the nth term? How would you express the formula for the nth term? Any guesses? It's not rocket science. It's not a trick question either. Just what do you think? Pause the video and just think about it. The nth term would be represented by adding the term previous to the nth term with the number 2 terms before. Wouldn't that make sense? This is an example of a recursive formula. A formula where the formula itself involves previous existing terms. Yeah, that's all there is. all we got to do is make the distinction between a recursive formula versus an explicit formula and get some practice. So here is a practice question. If the first term in my mystery sequence is a 3, and my recursive formula is t n minus 1 minus 2, find t4. Okay. I'm going to do this one for you, just to give it a shot, just so that you know how to go about with the textbook. Well, because this is a recursive formula, you have no choice but to actually figure out manually the second term, then the third term, so that you can figure out the fourth term. Another way of explaining is, if you want T4, I need T3. And if I want T3, I need T2. And if I want T2, I need T1. Hey, T1's given. Are you ready for this? Let's start. T2 is equal to T1 minus 2, which is 3 minus 2. That's a 1. Great. T3 is equal to T2 minus 2. What's T2? 1. Great. That means T4 is T3 minus 2. And what's T3? Negative 1 minus 2. There it is. Done. Another one. This time I'm going to give a recursive formula in a function notation. Here's an example of what that might look like. Oopsies. Here we go. Here's another example. If f of 1 equals 1 over 2, and f of n is equal to f of n minus 1 plus 3 over 2. Find f4. Again, if you want f4, you need f3. If you want f3, you need f2. And if you want f2, you need f1. So let's do it. f1 would be half plus 3 over 2, 1. f of 3 is equal to f of 2 plus 3 over 2, which is 1 plus 3 over 2, which is 5 over 2. That means f of 4 is 5 over 2 plus 3 over 2, which is 8 over 2. That's a 4. Done. This is recursive formula. It's not necessarily complicated in itself, but the puzzles, depending on the challenge level of the puzzles, it can become a little bit confusing. So let's get practice to make sure you've built some confidence in it. Page 376, numbers 1, 3, 4, 7, 8, A, C, D, E, and 11. If these videos are not enough in terms of explanation, you may see a Waterloo, the CEMC link to the Waterloo website. It's a full-out module that goes through lots of different practices. Please make use of whatever resources available for you. And as I said before, I will be making myself available in an office hour. Please drop in, ask a question, email, and I'll make a quick video explaining whatever question you might have. And not just to you, but it also might be beneficial to other people who might have the same question. Please don't be shy. Again, use whatever resources you have, and hope to see you soon. Bye.